Hello friends, welcome to my channel Together with Abhi. In this video, we are going to start with the new module which is Amazon RDS. This is a database related module. However, we are going to just cover it from a very high level because otherwise it requires a complete course of its own. Okay, but I will try my best to cover the main points, the main significant points that are required from to be known from a interview, certification and day-to-day activities point of view. Okay, so let's get started. As you would know, the database usually consists of two types. One is relational database, which mainly covers databases which are mainly done as part of tables. In the form of tables, we create rows and tables. So those are mainly called as relational databases. However, certain new databases called as non-relational database, or else we even say them as a NoSQL database, have come lately into the picture in the market and picking up really great strength. Why are they developing so much of publicity or noise these days? Is because these are quite simple to use, these are more flexible, they provide horizontal scaling, and they are not have a very defined schema from the very start. They have a flexible schema, you can use key value store. So these are really good from the point of view of the kind of data which is getting developed these days. Okay, in traditional relational database system, we usually have like some kind of a restriction. So that is why non-relational database are picking up very fast. Now within relational database, you would have seen two kind of divisions as well. One is an online transaction processing and the other is online analytical processing. So what is the difference between these two? If in case, let's say we have a web banking database, you would want to just know that what's the balance in your account. So this is kind of a very simple query. Okay, so you do some kind of select query and where the account number is this account ID, whatever. So it is a very simple query, and these kind of transactions happen very frequently. So these are called as online transaction processing. But as you would see, the analysis has become a really important cornerstone of our IT area these days. We want too much of an analysis on the data that we have. This requires different kind of database because we are dealing with complex queries. So let's say if in case we mold the example that I just quoted, and now I want to know, from the past 10 years, what all kind of transactions I have done which are greater than this value or less than this value between this period or that period. So when these kind of joins happen, when you require that multiple tables be joined and we come to some conclusion or outcome using that data after analysis, then that requires more complicated queries. These are not very frequent transactions. These come mostly under the purview of a data warehouse, which is like a consolidated database, multiple databases consolidated at a particular place, which is called a data warehouse. So this is mainly the difference between OLTP, OLAP, and non-relational databases. Now, in terms of Amazon, what all kind of services Amazon provides to deal with all these three scenarios? So traditional OLTP systems are provided as 6 database engines: MySQL, Oracle, MSQL, and MariaDB, and Amazon Aurora. Amazon Aurora is the new entry in the market, which is provided by Amazon. This is very significantly faster, provides distributed architecture over MySQL, and at a very low cost. So this is the main entry by Amazon. Otherwise, traditional systems, the differences which are traditionally within other database engine stands true here as well. The other question which is usually asked is related to Amazon Redshift and Amazon DynamoDB. Redshift is the main specific database engine which is used for analytical purpose. That's why whenever a question comes related to analysis or data warehouse, you should always go for Amazon Redshift. And for non-relational database, it is the Amazon DB. So questions are usually asked around these three: Amazon Aurora, Redshift, and DynamoDB. Now let's see, if in case we had to set up our own database, how would we have done it? We would have had our own machine, our own server within our own premises, and we would have created or installed a DB engine. It could be a MySQL, MSQL, or any other like MariaDB, PostgreSQL, anything, and we will have to take care of all the maintenance activities like patching, security updates, regular backups, replication. Everything is our headache. So this is an on-premises. Now with on-premises, the problem is you also have to take care of the operating system maintenance. If in case you want to save yourself from the Amazon, from the OS system maintenance, then you can rely on EC2 instance. So we do not want to do OS related activities. So we started using EC2 instance because Amazon is now going to take care of all those activities. But on top of EC2 instance, now I'm installing a database engine of my own. Again, the headache for database patching, security, backup, replication lies with me. So this is also, it is a better option than on-premises, but not as good as the third option, which is Amazon RDS. So Amazon RDS, which stands for Amazon Relational Database Service, which we are talking about today, it provides you a service wherein it is going to launch a DB2 instance, a database instance for DB instance rather, sorry, not DB2, it's a DB instance. A DB instance is going to launch for you, just like an EC2 instance, but you can choose the database engine that you want it to be installed or used. So you can have all those options, which kind of compute and memory you want. But now the headache of maintaining all the activities related to security, patching, backup, scaling, replication, etc. is offloaded to Amazon. So you do not have to do anything about it. The most important thing which is asked here and which makes a very significant impact is, like in case of EC2 instance or on-premises instance, you cannot just connect to this DB server through shell. Okay? You cannot do like SSH or RDP to this instance. The only way you can connect to your database is through traditional methods like SQL Workbench or SQL Client and all those stuff. Okay, so DB instance. So what when we'll go to the demo part of it, what you will see is we will be creating a DB instance just like an EC2 instance. We are going to select the compute, memory, etc., which is defined in the DB class, DB instance class. On top of it, we are going to select the engine, which could be MySQL, PostgreSQL, etc. We can select the kind of storage. As I mentioned, we had covered EBS, Elastic Block Store, in the last module, and where we told about that these are really very fast and which are very suited for the DB purpose. Okay, now again they had three options: magnetic, general purpose, and provisioned IOAPS. These stand true and valid in this case. The same services, everything is same, we just have the option of selecting it. Now within DB instance, the key points are, again, you can launch it through AWS console or through API. For API, you have commands like create DB instance or modify DB instance. And as I mentioned to you, you have all the control of selecting your parameter group, option group, etc. for configuration settings and features. Okay. Now let's go to backup and recovery, which is a very important part. DB is a very significant entity for any company, for any organization. DB is the most important part because everything is stored within your database. Now you would still really want to have your backups of the system. So Amazon provides you with a feature wherein it is going to automatically take backups for you. Okay, so it is going to continuously track the changes and backs up the DB, creates a storage volume snapshot of the DB instance. By default, the retention period is 1 day, but if in case you want, you can retain it up to 35 days by customizing it. Important question which is usually asked is automated backups are deleted on deletion of DB instance. Okay, so whenever you are going to delete a DB instance, your automated backups are also going to get deleted. Now, however, a few companies would just not want to rely on automated backups because the time difference could be more. If you, in case you want to rely on your manual backups or manual snapshots, you can do that. So creation of snapshot manually through API or through console. Again, you can do it through console or through API using the commands like create DB snapshot and delete DB snapshot for deleting those snapshots. Important significant difference with respect to automated backups: manual snapshots are not deleted even after deletion of DB instance unless explicitly deleted. So this is a very significant thing to understand. Now, any company, any organization, and the DBs within that organization, they are very much fishy about recovery point objective and recovery time objective. What are these things? Recovery point objective is the maximum period of data loss that is acceptable in the event of a failure or incident. So your DB instance goes for a toss. There is some failure or incident, but you want to save your data. You do not want to lose your data. So how much data you can accept to be lost is what is defined through recovery point objective. Usually you would not want to lose any data, or you would just want to lose minimal data. That's why this is usually kept in minutes, okay, just 1 minute or 2 minutes. Recovery time objective is once the system has gone down, okay, how much time it is going to take for you to get it back up, okay. This is recovery time objective. So you would it usually takes quite a lot of time to revive your system again from the backups and to resume processing. So this could be in hours or minutes as well. Using these combinations of automated backups, manual snapshots, and other things that we are going to study in the next slide, we actually configure this recovery point objective and recovery time objective as per our need. So next thing we are going to study about is high availability with multiple availability zones. As you know, availability zone is an important feature of Amazon. If in case you have created your database instance within one availability zone, and say for instance that availability zone, it encounters a failure for some reason, you do not want your system to go for a toss for always. So what you can do is you can create a secondary instance in another availability zone. So in case of failover, Amazon will automatically offload your task to your secondary instance. So you do not have to do anything. To handle this, a DNS endpoint is made available to you. So everything has been configured. You are just accessing your DB instance, be it primary or secondary, using the same DNS. So you don't have to do anything in case of a failure. Please note, this is only for disaster recovery. This is not for performance related activity. In case of performance related activities, what you would want to do is you would want to scale up your system. Either you want to have a vertical scaling or a horizontal scaling. What is vertical scaling? Let's say the number of transactions are getting increased within your system. So you would want to increase the memory compute of your primary instance, right? But there would be some limit. There would be some threshold up to which point you can increase your compute or memory. Okay. After that, what you would need is a horizontal scaling. Okay, so as part of horizontal scaling, what we do is we create a read replica. We are creating a replica of my DB instance. So a primary instance is my DB primary instance. We create secondary instance, which is not secondary asset. It is complete replica, but it is only for read purpose. So all the read related queries are offloaded to this replica, and the primary instance, it is only taking care of other activities. So the data load is offloaded. So you are able to, your primary instance is able to carry on with multiple other transactions because the read related queries have been redirected to another replica. So important to note, this is a performance related thing. High availability with multiple AZ is just for disaster recovery. But again, here also what you can do is you can take the advantage of availability zones by putting your read replicas in different availability zone, again for the purpose of disaster recovery. So I believe these are the main things that I wanted to discuss. In the next video, we are going to mainly cover about quickly the demo, how you can create a DB instance, create up a database, what are the important things, snapshots and all those stuff. Again, as I mentioned to you, this in itself requires a completely new course. In case you are interested, please let me know and I can cover that. But for now, let's quickly go through a few questions and answers which could be of use in case of interviews and certifications, and just to give you an idea on how questions could revolve around Amazon RDS. So the first question is, what action should be taken to ensure quick failover for multi-availability zone enabled RDS instance which has gone down recently? So your RDS instance already have multiple availability zone configured for failover. Now the instance has fallen down. What will you do? So as I mentioned to you, you do not need to take any action. Amazon will take action on its own. Failover will happen automatically. You do not need to do anything. Okay, so the correct answer is no action is required. Failover will happen automatically. Which AWS database service is best suited for running complex queries for analytical purpose in your data warehouse? As I told to you, most questions revolve around DynamoDB, Redshift, and Amazon Aurora. Redshift is for OLAP purpose, DynamoDB is a NoSQL database, and Aurora is the specific service which Amazon is promoting as part of OLTP. Now the question here asks for analytical purpose, so that is an OLAP. So the correct answer is Amazon Redshift. Okay. The third question is, which Amazon RDS database engines support read replicas? Now we have not covered in this course about database engines which support read replicas. Why I have put this question is, I just want to let you know that you can go to Amazon AWS website. There you will get all these details related to all the database engines. Okay, you can go through them, MySQL, MariaDB, what features do they have, whether they support read replicas or not. Why am I not covering it here? Because this information keeps on getting updated and changed as and when some new features get launched. So at the time when you are going for interview or certification, you actually need to go through all this data yourself. But still the correct answer here is MySQL, MariaDB, PostGreSQL, and Aurora. So guys, that's all for today. See you in the next video where we are going to cover the practical part of Amazon RDS. Hope you liked this video. If you did, please like it, share, and comment. Thanks for your time. Thank you.